Welcome to Physics for Good. I'm Allison, and today I want to talk about the law of reflection. Now, I know this is a little bit gimmicky, and my mirror is scratched, but I'm doing it to make a point, which is that you already understand the law of reflection. So there may be some new terms, a couple variables that you didn't know, but you participate in the law of reflection all the time. And so when I introduce it to my students, I tell them it's going to be their favorite equation all semester long, because it is just that the angle of incidence is equal to the angle of reflection. But what does that mean? So here I have a side view mirror, and the first thing I want you to notice is the normal line. The normal line is the little dashed line that I've drawn. In real life, it's imaginary, but it's always going to be perpendicular to the surface of the mirror. In fact, that's what normal means. Normal means perpendicular. Now you can see from the paper, we also have an angle of incidence and an angle of reflection. Well, what does that mean? Well, if I bring my laser pointer in here, and I point it at the mirror, we're going to have an incident ray, right? Incident means beginning, so we have my beginning ray coming out of the laser. But of course, because I'm shining it at a mirror, we're also going to have a reflected ray. There's our reflected ray. And so this angle of incidence between the normal line and the incident ray is going to be equal to the angle of reflection between the normal line and the reflected ray. That's what the law of reflection says. And it's always true, even if we change this, right? I've made the angle of incidence greater, but, there we go. I've also made the angle of reflection bigger. They're still the same. That's what the law of reflection says. And we know this, right? So imagine that this was a wall at a party, and you're standing over here in the room, you want to see somebody over here. You're not going to look directly down at the mirror, right? That would be silly. You're going to look this way so that you can see someone over here, and that light ray bouncing off the mirror will enter your eyes. The other thing that the law of reflection says is that these all have to be in the same plane, right? The angle of reflection, the angle of incidence, and the normal line all have to lie in the same plane. And we know that too by intuition. If I shine the light here, we know it's going to bounce right here. It's not going to come bouncing off here. That's silly. It's all going to stay within the plane of the paper. So we understand the law of reflection. We use it all the time. And in fact, we use it when we're driving. This is a side mirror. And we need to be very careful to use the law of reflection when we're thinking about our blind spots, and especially when it comes to bicycles. Which leads me to WeCycle, a strategic component of a low-income housing development in Mesa, Arizona. I talked to the founder, Robert Chacon, about his desire to increase awareness and independence in the community as well as help the environment.
WeCycle is a nonprofit recycling bikes for kids and adults in need. We have a community bike shop that people are allowed to come into, work on their bikes for free, and also if they don't have a bike, they can either at 16 or older earn a bike, or if you're under 16 years old, you can get a bike for free. So children get bikes for free as well.
How do they earn bikes?
Anybody who is 16 or older can work 8 hours in the shop. If they complete their 8 hours volunteering, they will be entitled to get a bike. And they get to pick a bike out from all the bikes that we have. We have hundreds of bikes to select from. The only catch is that the bikes are need work on them. So they're not, brand new bikes. They're used bikes, they're recycled bikes, and we will help them fix that bike and make sure it's safe to go on the road.
That's awesome. Okay. And so Robert is going to teach me how to install the reflectors.
Okay, so a lot of people unfortunately take the reflectors off their bike. They don't like them for some reason on their bike, and some people have lights, but then the white lights go out and they don't have the reflection anymore. So it's good to have reflectors as a backup in case your lights go out of power and you still have the reflectors on the bike and you can be seen at night if a light hits your bike reflector. This reflector here just requires one screw on the inside,
okay,
and then tighten this one with a Phillips screwdriver.
Can do.
Okay, so once that's tightened, you want to make sure that you're above the back tire,
okay,
so that you can be seen.
Okay.
So if you look at it from this angle,
okay,
you do see that you can see the reflection.
yes.
Okay? And you can also adjust this angle of this guy right here, so if you loosen this screw there,
Okay.
that allows you to turn this and then tighten it back again. Okay, so that covers your back reflector.
Awesome.
Now we have a couple reflectors on the ground there. Everybody the front.
Okay.
And then you screw it tight.
Everybody. Is that right?
Yeah, like a small.
That way, if a car is coming at your bicycle, it can see a reflection of its lights in this reflector, and it'll let them know to look out for you.
Good. I know it's good.
Now at this point, you might be wondering, how does a bike reflector work? After all, we've been talking about the law of reflection. Well, I wondered the same thing. So I bought a bike reflector, and I pried it apart. There are different regions, but within each region, you can see there are tiny mirrors angled 90 degrees to each other. The internet tells me that if you shine a light on two mirrors 90 degrees from each other, then the light will reflect right back at you, parallel to the original incident ray. But I don't believe random things the internet tells me, unless I verify it for myself. So here I have a diagram of two mirrors 90 degrees apart. I've drawn my incident ray and my normal line and measured my angle of incidence. Now I have to draw my angle of reflection and my reflected ray. And of course my angle of reflection has to be equal to my angle of incidence. Now my reflected ray for the first mirror is going to be my incident ray for the second mirror. And so then I have to draw my normal line, and I'm going to measure what now is becoming the angle of incidence for the second mirror. And then I have to draw my reflected ray, where the angle of reflection is equal to the angle of incidence for the second mirror. Sure enough, that reflected ray is parallel to our original incident ray. The light is reflected right back at us. We can verify this experimentally too, and this is how a bike reflector works. Because of the 90-degree angles between the mirrors, your headlights get reflected right back at you. But back to WeCycle, who will be receiving 50% of the ad revenue generated from this video. How else can people help you besides just watching this video?
Well, WeCycle has a website called WeCycleUSA.org. You can go on that website and you can click the link to use your credit card to give us a donation and help us keep this shop going.
Thanks for watching. If you like what you just saw, please consider subscribing right here and sharing the video with a friend. Also, check out the video description where you'll find a link to the charity you just saw, as well as some affiliate links.